In section 3.5, we're looking at writing and graphing equations of lines. And this carries over from what we saw in the last section, which was looking at parallel and perpendicular slopes when looking at equations. So we actually have two ways we can graph. The first one, and probably the more common method you're familiar with, is slope-intercept form, which is written as y equals mx plus b. In that case, the m stands for, like we talked about last time, and that's slope. And slope is the change in y over the change in x. We also talked about being rise over run, and you had slope formula along with that. The b is the y-intercept. Or in other words, it's where the line hits the y-axis. If we don't remember, the y-axis is the vertical and the x is the horizontal. So, our steps for graphing with slope-intercept. First off, we mark the y-intercept. Which is b. Then, use the slope to find another point from b. And last, use the 2 points to draw a line, which we talked about before. You need 2 points to draw a line. Okay, so let's pick an example. Let's say I have y equals 3 over 2x minus 2. So first off, I see that slope is 3 over 2, and y-intercept is negative 2. The first thing we're going to do is y-intercept. So at negative 2 is our y-intercept, and that's actually 0, negative 2 if it was a coordinate. From there we go up 3 over 2, because that's our slope. 1, 2, 3 over 2. That's our new point. You could draw it like a little triangle. That's 3 and 2. 2 points give us a line, and we can draw our equation in. Now, we could have kept going up 3 over 2 and kept marking points, and that would be fine, but if you have a straight edge, mark off 2 of your points, draw the line, and you're set. Okay, so that's slope-intercept, something you've probably done in your last class. But let's relate that to using parallel and perpendicular lines, which really is the focus here. So if we have y equals mx plus b, the slope will be key for finding / identifying parallel and perpendicular lines. So let's start with parallel first. Parallel lines, like we talked about before, have the same slope. So if I have y equals 3x plus 2 and y equals 3x minus 10, both cases m is 3, so they are parallel. If I have y equals negative 1/2 x plus 7 and y equals negative 1/2 x, well, I do have a y-intercept here, it's just actually 0. In both cases, the slope is negative 1/2, so that's parallel. If they are not the same, if this coefficient to x, this m value is not the same, they're not parallel, and that's enough from that. You do have to know how to graph to verify, but just looking at the equations, it will tell you whether or not they're parallel. Now we go to perpendicular. We talked about perpendiculars m1 times m2, or if we multiply the slopes, or their product is negative 1. You could also look at the saying the two slopes are opposite reciprocals of one another. So let's say we have y equals negative 3x plus 4 and y equals 1/3 x plus 1. When I look at the two slopes, I have negative 3 and I have 1/3. If I multiply those together, it comes out to be negative 1. That's enough to say that they are perpendicular. But you can also realize, well, from negative 3 to positive 1/3, they are in fact opposite reciprocals of each other, which does mean they are perpendicular. This doesn't graph it, this doesn't verify it, but it gives us the hint before we go into graphing the problem, whether it's going to be parallel, whether it's going to be perpendicular. So just by reading the equation, you can identify what types you're going to have, which will make it easier to find what you're looking for. Now, the other method we have is standard form. So, go through, at least identify what standard form is, and see how we can use it. It is a little bit different approach. So we have ax plus by equals c. And in standard form, the y-intercept is c over b. The x-intercept is c over a. And the slope is negative a over b. Now the y-intercept and the x-intercept, we actually get those from setting the opposite variable to 0. So if I set a equal to 0, or x equal to 0, and I solve for y, I would get c over b. If I set x equal or y equal to 0, and I solve for x, I would get c over a, which give me each of the intercepts. So that's maybe a shortcut for it. Now, keep in mind here that a, b, and c are coefficients that indicate the equation. Let's say the graph. So as these values change, the graph will change. Same idea with m and b. Now, it's just not as direct as slope-intercept, but you may see it in standard form. So let's pick an example. Let's say I have 3x plus 4y equals 12. And this is a, b, c. If I wanted the y-intercept, that would be c over b, which is 12 over 4, or 3. If I wanted the x-intercept, that would be c over a, 12 over 3, which is 4, which I can plot those points. Y is 3, x is 4. I can draw a line through that. And I get my equation, which is 3x plus 4y equals 12. Now I could also see here that the slope, we said, was negative a over b. So that's negative 3 over 4. And if we look, I did go down 3 over 4, so that does give us enough. But really for standard form, if you can find the x-intercept and the y-intercept, you can graph the line. But maybe this doesn't work for you. So we could pick a big or, convert standard form to slope-intercept. We're going to do it using this general form, and then we'll look at this equation to verify. So if I have ax plus by equals c, let's treat it like a proof. I'm given that. I could subtract ax from both sides. So I'm going to subtract, or use subtraction, ax. Leaves me with by equals negative ax plus c. Now I'm going to divide, use division for b to get y by itself, and I get negative a over bx plus c over b. So now this is in slope-intercept, but let's look at the pattern here. In slope-intercept, we said that this was the slope. Well, that matches, so that matches in standard form. We said this was the y-intercept. That matches as well. So we could convert, and it still does fit. But I wouldn't expect you to do it in this form. Let's take the one we just had. 3x plus 4y equals 12. I subtract 3x from both sides. I divide by 4, and I get this equation. Does that equation match? Yeah. Y-intercept is 3. I go down 3 over 4. So really, you could use standard form, but it is another method in terms of graphing, or change it to slope-intercept. It doesn't matter. It still gets you to the same result. Most of the time you see slope-intercept, so maybe that is a benefit of doing that, but it is a form, and you do need to be aware of it. So let's go through and start graphing some. So I'm going to graph and slope-intercept for these two graphs. So y equals mx plus b. I need to find slope. I need to find y-intercept. So I look at this one. Right off the bat, I see my graph hits the y-axis at -4. So I know b is -4. If I look at the slope, it goes up 1, 2, 3, 4, and over 1, 2, 3. So the slope is 4 over 3. So y equals 4/3 x plus -4, or we could just write it as 4/3 x minus 4. Okay, we go to our next one. So right off the bat, we can see our slope, 1, 2, 3, 4, 5, 6 down, 1, 2, 3, 4 over. So our slope is -6 over 4, or -3 over 2. But the y-intercept we're not sure about. It's kind of in between those points. And in fact, we don't have a point on that line. This brings up a way we're going to have to solve. So we know this is our equation. We have m is -3 over 2. But we need b. We don't automatically know it. So if we had a way to solve with x and y, we could solve for b. But if we think about it, x and y are really a point on the equation. So I'm going to plug 1 in for x, -2 in for y. So -2 equals -3 over 2 times 1 plus b. So I get -2 equals -3 over 2 plus b. I'm going to change this to make it have a denominator of 2. So they have common denominators. So I'm going to add 3/2 to this side. If I add, it leaves me with -1/2 equals b. There's my y-intercept, so I can say -3 over 2x minus 1/2 is my equation. Okay, a couple others here. Write the equation and slope-intercept. Well, this one they tell us right off the bat, if it's y equals mx plus b, we can substitute in y equals 3x plus 2. Same here. Y equals -11 over 5x minus 12. This one means we would go down to -12 for our y-intercept, and our slope would be down 11, 5 to the right. Okay, we go to our next one. Y equals mx plus b. Right off the bat, we know that m is 4, but we don't know our y-intercept. Now, this point we do know is xy. So I'm going to substitute in 4 for y, 5 for x. So b is -16 once I solve. So now I can put it back up here, and it's 4x plus, how about minus 16, I'll write it a little better. Y equals 4x minus 16 as my equation. Okay, on our next one, we need to write the equation that passes through this point and parallel to that equation. I'm just going to sketch this out to get an idea. So this equation has a y-intercept of 3 and a negative slope, so it looks something like that. And the point I have is 0, -1. So that's right there. I want to find a parallel line that goes through that point. I want to find a line through that point that's parallel to it. Well, parallel tells us we already know our slope. Because the slope has to be the same as that one, it's -2. So all we need left is the y-intercept. Now I could use these as points for x and y, plug them in and solve, but wait, isn't this the y-intercept? Isn't the fact that 0, -1 tell us -1 is our y-intercept? So our equation is -2x minus 1. In our last one here, we do the same approach, but now we want perpendicular. So I still have this equation. I still want to go through this point, but it needs to be perpendicular. Well, if my slope is -2, the slope of the perpendicular is the opposite reciprocal. -2 becomes positive 1/2. Now we still need our y-intercept, but it still works the same way here. Still goes through 0, 1, so that's still, or 0, -1, so that's -1. So our equation is 1/2 x minus 1. Notice in both of these, slopes stayed the same or slopes were the opposite reciprocals. Without necessarily graphing the equations, we can find whether they're parallel or perpendicular, or find the line that is parallel and perpendicular to it just by looking at the equations. Use those as the shortcuts and you should be all right.